Hi everyone, my name is Hamza from ECE department and today's my topic is tuned amplifier. So let's get started. Tuned amplifier definition: an amplifier circuit in which the load circuit is a tank circuit such that it can be tuned to pass or amplify selection of a desired frequency or a narrow band of frequency is known as tuned circuit amplifier. Tuned amplifier characteristic: Tune amplifier selects and amplifies a signal frequency from a mixture of a frequency in any frequency range. A tune amplifier employs a tuned circuit. It uses the phenomena of resonance and the tank circuit, which is capable of selecting a particular or relative narrow band of frequency. The center of this frequency band is the resonant frequency of a tuned circuit. Both types consist of an inductance L and capacitance C with two elements connect in series and parallel. Resonance circuits: when at particular frequency the inductive reactance becomes equal to capacitive reactance and the circuit then behaves as purely resistive circuit. This phenomenon is called the resonance and the corresponding frequency is called the resultant frequency. Classification of tune amplifier. Tune amplifier are classified into two categories: small and large signal. In small signal, whereas we amplify low RF signal, whereas in large signal we amplify large RF signal. Here output is low and large signal output is more. In small signal we have A class operate, and in large signal we have B class and C class or class AB mode. In small signal we have three categories in A class: single tune amplifier, double tune amplifier and staggered tune amplifier. Single tune amplifier are further classified as capacitive coupled, transformer coupled or inductive coupled. Single tune amplifier circuit diagram. Single tune amplifier consists of only one tank circuit and the amplifying frequency range is determined by it. By giving signal to its input terminal of various frequency range, the tank circuit on its collector deliver high impedance on resonant frequency. Thus the amplified signal is completely available on the output terminal, and for input signal other than resonant frequency, the tank circuit provides lower impedance, hence most of the signal get attenuated at the collector terminal. Limitation: these tune amplifiers are required to be highly selective, but high selectivity requires a tuned circuit with a high Q factor. A high Q factor circuit will give a high A, but at the same time it will give much reduced bandwidth because bandwidth is inversely proportional to the Q factor. It means the tune amplifier with reduced bandwidth may not be able to amplify equally the complete band of the signal and result in poor reproduction. This is called potential invisibility in tuned amplifier. Double tune amplifier circuit diagram. Double tune amplifier consists of inductively coupled two tune amplifier, only L1 C1 and the other L2 C2 in the collector terminal. A change in the coupling of the two tune circuit results in a change in the shape of the frequency response curve. By proper adjustment of the coupling between the two coils of the two tune circuits, the required results: high selectivity, high voltage gain, and required bandwidth may be obtained. Resonance curve of parallel resonance circuit diagram. Staggered tune amplifier circuit diagram. Staggered tune amplifier are used to improve the overall frequency response of tune amplifier. Staggered tune amplifier are usually designed so that the overall response exhibit maximal flatness around the center frequency. It needed a number of tuned circuits operating in union. The overall frequency response of the staggered tune amplifier is obtained by adding the individual response together. Since the resonance frequency of different tuned circuits are displaced or staggered, they are referred as staggered tune amplifier. The main advantage of staggered tune amplifier is increased bandwidth. Its drawback is reduced selectivity and critical tuning of many tank circuits. They are used in RF amplifier stage in radio receiver. The staggered tuning in the circuit is achieved by resonating the tune circuit L1, C1, L2, C2 to slightly different frequencies. Bar graph of staggered tune amplifier. Class C tune amplifier. Class C tune amplifier are based so that conduction occurs for much less than 180 degrees. Class C amplifier are more efficient than either Class A or push-pull Class B and Class AB, which means that more output power can be obtained from Class C operations. The output amplitude is a nonlinear function of input, so Class C amplifiers are not used for linear amplification. They are generally used in radio frequency RF application, including circuits such as accelerators that have a constant output amplitude modulator where a high frequency signal is controlled by a low frequency signal. Therefore, the Class C amplifiers are also called tuned amplifier. Class C tune amplifier circuit diagram. Class C tune amplifier. Because the collector voltage output is not a replica of the input, the resistivity load Class C amplifier alone is of no value in linear application. It is therefore necessary to use a Class C amplifier with a parallel resonance circuit tank. The short pulse of the collector current of each cycle of the input initiate and sustain the oscillation of the tank circuit so that the output sinusoidal voltage is produced. The tank circuit has high impedance only near the resonant frequency, so the gain is large only at the frequency. Sharpness of resonant curve. The resonant curve is required to be sharp as possible in order to provide a high selectivity. A sharp resonant curve means that the impedance falls off rapidly as the frequency is varied above the below the resonant frequency. We need to know what's the application of tune amplifier. So what's our uses of tune amplifier? The tune amplifiers serve the best for two purposes. A. Selection of desired frequency, or B. Amplifying the signal to a desired level. So, advantage of tune amplifier. It provides high selectivity. It has small collector voltage. Power loss is also less. Signal to noise ratio of output is good. They are well suited for radio transmit and receiver. Disadvantages. They are not suitable to amplify audio frequency. If the band of frequency is increased, then design become complex. Since they use inductors and capacitors as tuning element, the circuit is bulky and costly.